And we're live. Welcome back to another Corona Geek, here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever, and today is a continuation of last week's topic on physics. We started a whole series on creating physics bodies and working with joints and creating rag dolls, and there was even a wheeled cart, some wheeled cart action in there. So if you didn't have a chance to go see Corona Geek, what is it, 146 now? Then go over to youtube.com/coronageek and check that out. There is a sampler there, well, along with all the sample code that we played with, and you can kind of pick things apart and see how it is all constructed. Joining us on the panel today is Dr. Brian Burton from burtonsmediagroup.com.
Hello.
How you doing?
I'm doing great.
Also joining us is Ed Marina from roaminggamer.com. And then Steven is joining us down. Are you still down in Mexico? He is. He's shaking his head yes. So, all right. That doesn't qualify as down under, does it? That's a whole different thing. What's the Margaritaville? Is that okay? I know. So today we're going to continue our conversation on physics. I know last time we kind of went through some things like how to troubleshoot physics objects, which was very helpful, I think. We talked about kind of how turning on hybrid mode helped with that. Also, I think, wasn't there we had a conversation on objects that were sleeping as well, right?
Yes, sleeping.
Which I thought was a very interesting conversation about how each of those objects would go to sleep, and then just before they were going to be interacted with, they would be woken up, I guess you could say, and then that, that made a difference in how things interacted with each other. So, I don't know. Do we have any announcements for this week? Does anybody on the panel want to go first?
I have a forthcoming game. It will very soon. We're in the final stages of testing it, but very simple. But hopefully very addictive game that will be out very soon.
Hopefully very addictive.
Hopefully.
Your money.
And all of our play testing has been very addictive. So
I'm looking forward to ruining some lives.
That's right. Don't sleep, don't eat, don't do your job, just play
my game.
Yeah, this week in the news, the divorce rate went up.
2% on the release of.
That's right, exactly. Anybody else? Any other exciting news? Brian, do you do any sort of keyword research before you publish your apps? Or you kind of like you focus solely on the app itself?
I focus on the app.
Just on the app.
If I like it, I'm hoping other people will like it as well.
Well, yeah, I mean, I know there's.
I make games first for me.
I totally agree because so far everything that I've published has been something that I like to play first, and I think that helps me to want to actually work on the thing.
Right.
But when I go to publish, I start thinking about keywords and stuff and how people are going to find it. I didn't know if you guys.
Right. I do a little bit of research on that, not as much as I probably should do.
Yeah.
But I rely on things like Corona Geek to let people know it's out there. So.
All right. So, yeah. The ASO thing just seems like it's kind of a waving of the hands, but
it is. Yeah, it's magic happens and then suddenly you're popular.
Right. And then there's a store change and then you're not popular.
Right. And it is definitely a moving target that you're shooting at with ASO. So it's. Yeah. I'll do a little bit of research and continue to tweak it as time goes by. But it is a continuous tweaking thing. You know, all the popular apps, assuming we're not talking about something that was created by a huge celebrity, or George Takai tweets about it or something like that. We are very dependent upon people finding it, reviewing it, tweeting about it, saying they enjoyed playing the game, and just the luck of the draw for the success of our app.
Yeah. Do you guys do any sort of? Do you send it to friends and family and ask them to play test or anything, or what do you?
Yes.
Yeah. Do you get a good response rate on that? Do people actually, like?
So far,
Sometimes it can be hard to get the people who know you the most. They're
right.
I
tend to keep my testing circle fairly small. Then I'll try and get something out there, and then I'll demonstrate it to my class, And that gets me at least 20 or 30 people downloading it usually.
Oh yeah, well
they need to play test it for class. So.
Right. Did I mention your grade? Your grade is dependent on your participation.
If you don't get a score of 1,000 on this, your success rate in the class could be in danger.
Well, Jason would definitely pass that class with flying colors. That's for
yes.
sure. So thanks for joining us, Jason. We got Jason Schroeder here from jasonschroeder.com.
Hello.
I love saying it like that, jasonschroeder.com.
I'm working on it. We'll call it a soft launch. I've had the idea for what I would call my one-man studio for a while, and I bought the domain name, so I guess it's a thing. So soon to be highfalutin software. I just like that word.
Highfalutin software.
So there's highfalutinsoftware.com and highfalut.in. I own both of them.
Oh, really? That's interesting.
So,
That's kind of creative.
And yeah, I think I'm working on a game right now that I hope to release by the end of the summer, and that'll be sort of the first one under that umbrella. So.
Oh, cool. So are you going to point your personal domain to something else?
Not sure yet. Right now, the highfalutin software just goes to my website. I haven't built anything out yet. I just sort of bought the domain. But I think I might try and separate. I think I'll keep jasonschroeder.com Corona-oriented and app dev-oriented, but I think I might, move some parts of it right now where descriptions of my apps and things off to the highfalutin side, certainly anything that's released under that umbrella, and then keep the blogging side of it. If I release a library or a module or whatever, I'll probably do that on my own site.
Yeah, that makes sense. Because once you get into the sort of the business side of things, you kind of need to present what we're about, products and services, examples of work, all that kind of stuff. Yeah, so interesting.
Yeah, I don't know. I mean, it's a vanity thing right now, truthfully. But, I thought, well, I always like that notion. I think if I have to call myself something, we'll do that. So, I've been working on my little splash screen. Like I said, vanity.
Yeah, that's cool. And that's good. It's this stuff that keeps us motivated. So, okay, well that's good. So just a reminder that we have this week and then next week. Really, I guess you have all of next week that you can play to participate in June's Corona Geek Games. We're playing Alone by Laser Dog Games, and then we're also playing 1.1 Target. So if you are interested in trying to win a $50 gift card, you definitely need to participate. Get a high score. Post it on the Corona Geek Facebook page over at facebook.com/CoronaGeek, and then we will announce the winner at the not next week, but the week after, and hopefully we'll draw your name from the hat. So we'll have links in the show notes to both of those games. You can play them; they're a lot of fun. So, Ed, how's it going?
So Ed is clicking away and getting this all set up to talk to.
Now, last week we kind of dug into the documentation. We looked at physics and how what the documentation said for the joints and stuff like that. And we also looked at the overview of how joints are constructed and how the ragdolls were constructed and stuff like that. I think this week we were actually going to get into the code.
Yeah, so this week I will avoid discussions about esoteric or other physics features. I think that perhaps we can come back and discuss some of those things later. For example, we got a little bit off topic last week talking about set continuous and some other features. I will clarify that I made a mistake last week on set continuous. Basically, set continuous is saying to continuously iterate to have the physics engine running nonstop. So whether or not a body is awake or asleep is irrelevant. What it's saying is basically just if it's in the awake pool, process it. And what that does is prevents errors. It reduces the likelihood of physics calculations errors that will show up as visual anomalies. For example, one thing which is called tunneling, where one object that is moving passes through another object when it should not. This happens with high-speed objects, and I will stop the discussion here, I think, because this gets complicated. Some people think, oh, tunneling is bullet is the solution. No, that is a solution, but there's more to it than that. So I think what we should do is, in a future show, not necessarily next week, is take apart some of these things like continuous processing or velocity iterations, some of these kind of weird topics that change the way the engine works, stepping, time steps, etc. This week, let's just go ahead and look at the actual examples. I lost my camera here, sorry. Let's go ahead and take a look at, go ahead.
Oh, I was going to say, and all those things like set continuous, all that kind of stuff like that, those definitely are not, I mean, those are, like you said, advanced topics, right? I mean, you don't really need to get to those until you have a need for them.
Absolutely. Most of those, you should leave them alone. They're not first-order solutions. Most of the problems people encounter in physics can be solved in other ways. Once you start tweaking continuous and the number of iterations and the step to time step, you're really messing with the guts, and they have side effects that can be kind of nasty. So I mean, unless you know exactly what you're doing. So I'm not saying don't do it. I'm just saying the first time you run into a problem, that's not the first solution. So
okay.
We can come back to it because like I said, I want to give it a proper coverage, which means giving it some proper research in advance, so I don't talk out of the side of my mouth. I.e., I don't say something that I don't know 100% that I'm right.
Well, I see you've got a sampler up here, so what's that about?
All right, so what we got here is the sampler. And this is it's a little bit different from what we had last week. There's a couple more samples in here, and it will continue to grow. But the way this sampler works is it's all in one folder, and you run it, and basically you can click on a sample, it will open it, you can play with it, play with the options on it, see how it works. Quit it when you want to by clicking back, and then go to another one. And the reason I did that was not only to give you the ability to go back and forth between the samples, but a lot of these samples you might be playing with, like the joint sampler, and you get it a certain way, and you're playing with it, and you're like, oh, this is pretty cool. You know, I'd really like to reset this. Well, just go back and reset it, and it's back in business. So you can play with it some more. The one that we're going to cover today, for sure, is the Draggable Doll, which is this guy right here, where we can drag him around and click anything that's green and drag that. And then I think we'll have time to talk about what I call the simple car example, which uses a pivot joint for the wheels. And I think that's going to be about it. I will point out that there is a joint sampler. You just saw it a moment ago. And in this sampler, I have made individual functions to generate the samples you're seeing here. So there's a function that generates a touch sample. There's a function that generates a weld sample, a pivot, a distance joint. And you can turn on hybrid rendering. One thing to note is if you start this, you run it, and then you click hybrid, nothing happens until you start moving things. And that's just the way the physics rendering works. It's basically gone to sleep. We talked about it last week. And I think that it doesn't know that it needs to switch into hybrid mode until something changes. So it's a minor detail, but people could get confused. So, but this is kind of a fun example. If you turn on the hybrid rendering and you turn on, say, gravity, you can start playing with things. And got a pulley joint over here, or this is, oh, it says rope. I'll correct that. It's supposed to say pulley. My bad. See, I was just working on this. All right, so back to, I'm going to reload, the Draggable Doll. So the point of this example was sort of where we started the whole discussion, which is we want to make a ragdoll. Now, for me, what a ragdoll is any kind of object approximating some kind of body, be it a human body or a dog or something with limbs, basically. And the rag part of it is saying to me that the arms and the legs and all the appendages should be attached to a main body, which may have one or more parts. And when the body moves, the appendages move, and vice versa, and they have a nice loose movement, just like a rag doll. In other words, with a rag doll, it's got what you could think of as joints, but they've got no strength other than to keep the body together from pulling apart. And so that's what we're seeing here, is when I turn gravity on and then I grab this thing and I swing them around. It's a little bit hard to see in the video, but basically everything just hangs freely and the joints all turn, and that's all there is to it. Goodbye, George. Sorry, I'm going to take a sip of coffee.
So we've named him now.
So the question is, reloading, how do we do this? Wrong sample. How do we make this? Last week, we examined the simple pivot joint example, and in that example, I showed you that I have a builder function whose job it is to build an arm or a leg, and in this case, this is the arm builder. And the arm is made up of a rectangle, the white part, and two marker dots. And the marker dots are attached to the rectangle with a weld joint. Stop that. Okay. So, and the reason I have my builder put together that way is not necessarily because it's the best or even the right way to build an arm, but simply as a starting point and to provide some visual feedback. Because what I wanted in this example was I wanted some kind of object to show you where the different positions were. If I didn't put these little dots here, differentiating the forearm from the bicep would be difficult because they're just two shapes that are the same color. So this gives us a nice visual representation. All right, so let me show you where the code lives. So for people who are going to follow along later, you're going to be able to download this project as a zip file, and the link is, we sent it out on the last show, and we'll send it out this time. And when you download it and unzip it, you're going to find yourself in a folder called Physics Fun. And in Physics Fun is your normal main config and build settings. This project uses SSK, so that's included. There's nothing in the scripts folder, and the images folder has got some basic, just placeholder art that I typically put in all my projects in case I need to draw something quickly. And IFC, which is short for interfaces. And each one of these interfaces is a scene file loaded by Composer. And for example, we're looking at one on the left here. And each one contains one of these examples. So for example, simple is in, where is it? Simple.lua. And the one we're going to look at today, Draggable Doll, is in doll.lua. And then we'll look at car a little bit later. So over here on the left, or now here on the top, I have doll.lua loaded. And this follows my standard format. I won't go too much into it. Basically a placeholder for a copyright, and I titled this wrongly, so let's say doll example. A title for the file. I load the Composer library. I create a scene. But one thing you need to do is you need to require the physics library, and I just like to require it at the top of the file so it can be used by all the functions and code below. At this point, this variable will be visible to all functions and code below this point. Then a section for local variables. For example, I'm going to create a series of display groups which I will organize from top to bottom and use them as a layering system, so I can have buttons that are always guaranteed to be over the content and the background is behind the content, etc. So I created a variable to contain that, and some more variables which I'll come back to and talk about in a moment. Forward declarations. So I use functions throughout my code, and what I like to do is declare the function at the top of the file, and then before I first use it, somewhere down below, I will define it. For example, create arm segment. I use this throughout the code. You can see that I'm using it here on line 170, 180, etc. But because I did not want to sort my file, I didn't want to define this before I created or used it, I simply forward declared it, and then I defined it below. That is, I assigned a value to it, so now it has a function attached to it. And then as long as it's defined prior to the first call, I can refer to it in any function that has visibility to that variable. So will enter is defined on line 101. And because I declared the variable on line 29, this variable, even though it has nothing in it yet, is visible to the function below. So just to step through this in case it was confusing, I declared on line 29, and then on line 101, I started to use or defined a function which refers to it. So the body of this function gets built up, but right here where I called create arm segment, it doesn't have anything yet, so that's a placeholder. It says, okay, hasn't been defined yet, but I have a placeholder for it. So it holds on to it, and then I finally define it, and then later on in this code, when this bit executes, it says, okay, I had a placeholder. Ah, look, now there's something there. I can call the function, and everything's good to go. So in a nutshell, forward declaration gives me a little bit of flexibility with how I organize my code, so I don't have to, if you get into, say, a chicken and an egg situation where a function A needs to call function B and function B needs to call function A, I know, that sounds a little bit weird, or say ABC, you can just forward declare them and then define them and then run them, and everything should be fine.
And then for anybody who's new to that concept, I mean, really defining everything at the top is just a housekeeping item, right?
Mm-hmm. It is. This is one of the ways that I do maintain my code organization. This is how I do my housekeeping. It's worth noting that Sergey made a wonderful suggestion when we talked about forward declarations some time ago. Because this is a composer scene, we've created a composer scene object. And this scene object, by default, has a number of methods already associated with functions. A method is nothing more than a function associated with an object. So we could say functions. It has a create function. It has a destroy function, which you are supposed to fill in the body, but it knows that it's going to exist. But what he said was, instead of forward declaring things, I could simply have said scene dot, let's say, can't type. Why don't I do it with the create arm segment? So create arm segment, instead of having forward declared it, I could have said scene dot create arm segment, and etc., just like I did before. And now, wherever I called it, I could have said scene dot create arm segment. Because scene, which was created at the top, has basically global visibility within the file, not to be confused with global everywhere, but file level visibility, I could simply have attached the function to my scene and then called it everywhere within the scene. And that's a nice way to organize too. So I didn't need to forward declare the variable. So I still haven't switched over to using that because I'm sort of stuck in a rut in a sense. I'm used to doing it my way. But this is another nice way to do it, is simply attach all the functions to your scene, and then they're visible to that scene anywhere that scene operates, be it within the file or called externally.
It's also a nice way to avoid bumping up against Lua's local limit, which I can't remember. Is it 64?
It's 200. Yeah, you're right.
Oh, 200. Okay.
There's a limit to 200 local variables defined within any scope at any time. And so if you have 100 local variables, file level, and you try to create 101 local levels in a function, the last one's not going to be there. You're going to run into the limit and your app will crash. So, what did I say? We're not going to get distracted with side topics, and I'm going on side topics.
Nah, that was my bad. Sorry about that.
No, it's okay. Well, I'm trying to lead people through the organization, but let's just go ahead and skip through here. If you're familiar with Composer, you're going to know that there's a create function. Now, the create function in all of these examples does nothing more than create a layer system. That is 3 display groups. which are layered on top of each other, where underlay is on the bottom, content is in the middle, and overlay is on top of all that. It creates a background image, which is this image with the squares that you see here and the red. And this is my traditional background image so that I can see how much overlap I've got in this particular display. For example, the application was designed to a resolution of 320 by 480, very old school iPhone 4 resolution. And my graphic image is designed to show me that this extra space here between the red and the side is, well, it's extra. It's unused width, or if I had done, say, an iPad, it would be a little bit taller and there'd be a black gap at the top and the bottom. It's just a point of reference for me when I'm doing my design. In other words, the guaranteed visible space is in the red block here, and everything outside is not guaranteed to be visible on all devices.
Do you do that in all your apps?
I do that generally in all of my apps, so that I know that if I have something that has to be fixed at a certain position within the design space, if I place it outside of this rectangle, then it's not going to be visible on all devices.
Gotcha.
Now, mostly, for example, see how this button here is adjusted to go all the way to the right?
Mm-hmm.
I simply place certain objects by the absolute width or height of the screen, which I've done in this case. So if I were to resize this and view it as, say, a borderless iPad, and then run the draggable thing, the buttons would be in a different place relative to this rectangle, but still in the same exact position relative to the side of the screen. So I placed this button and this button at the bottom relative to the side of the screen. Again, I use this background as purely a reminder of my guaranteed visible space, and so if I'm viewing this as sorry, wrong one, as an iPhone 4 style resolution, even though it was actually the new iPhone 4 resolution, you can see now that this is my guaranteed visible space, which is the same as my config Lua settings, 320 by 480, which comes up to 640 by 960. Okay, so create the background, that's this bit here, and a label to tell us what the example is, draggable ragdoll, as you can see at the top. Obviously this is going to change for the different ones. Posable ragdoll. And some buttons. And the buttons in this case are the back button. All of the scenes will have it, which just takes us back to the main menu. And then various different examples will have other buttons, usually in the upper right corner. In this case, gravity, hybrid mode, strength of the drag or touch joint. But in the case that we're looking at today, just a gravity button. And clicking it will toggle gravity, and then our ragdoll should fall down. Other than that, the create function doesn't do anything, and the reason is because I'm going to be coming in and out, and so I will create the content anew every time you enter the scene, and every time we have finished exiting it, I destroy all of the content, so the next time we come back in and I draw it again, there's nothing getting overdrawn. It's just a nice way for these examples to allow us to run the example, move things around, throw George off the screen. Sorry if anybody out there listening who their name is George. I apologize. And then we can run it again, and George is back. So, sorry.
Poor George.
Mm-hmm. I merely chose a name. Nobody is named George on the show, so we're good. All right. Sergey's not on the show, and then I threw Sergey off the screen. Where's Sergey's gonna come back and get me? Okay, so where's the guts of this? The guts of this example start on line 101 in the will enter method or function. Will enter is my own custom function. Traditionally in Composer, there is a function called show, I split it into two different parts. I look for the will phase, and I call my custom will enter. Or if it is the did phase, I call my did enter. And similarly, I do the same thing for will exit and did exit. And as I mentioned on the last show, I do this because I believe, if I recall correctly, Storyboard used to have the will and did concept built right into the method names, and so I wanted to maintain the same signature for people who are converting over from Storyboard to Composer. Also, it makes a lot more sense to me to split it out in advance, and then you don't have to think about it. You're thinking, I'm in the will segment. I never have to think about code being mixed in from the did segment or phase. So upon entering, the first thing we're going to do is we're going to start physics because every example stops it when it exits. And we will set gravity to 0 because we don't want George to fall initially. We want him to be in the standard pose position, which I'm going to talk about in a moment. At the top of this section here, we have our filter. We talked about this last week, but one of the cheater ways to create a bunch of physics bodies that do not collide with each other. So in other words, they collide, but there's no physics response. This rectangle here hits this rectangle, and it doesn't bounce off of it or get pushed away. The cheater's way to do that is to create a single filter with a group index of -1, and then use that filter for all bodies that you don't want to collide with each other. Now, that breaks down as soon as you want to start adding additional collision rules. But for this example, I don't want anything basically to collide with anything else except for the ground here. So all of the physics parts use that filter, and then the ground has no filter, and so these will collide with the ground. Ugh. Poor George, just getting beat today, I tell you. Okay, next, I put in some flags, local variables, where you can turn off a body part, and if I kept my logic right here, you should be able to do any particular one simply by selecting where it says true instead of false. And then what that will do is turn off, in this case, the right leg, but it will also turn off anything that depends upon the right leg being there. For example, the dragging code, all the body parts need to be present for the dragging code to work the way I wrote it. So that will turn off, that should turn off the dragging code. Let's go ahead and run it again. And there's no right leg, and now the body is yellow, which was the default color. Anything that is green is draggable, so we can no longer drag our doll, but we got rid of the right leg. We can get rid of the head. And let's get rid of the left arm. Poor George.
You get a weird looking false there.
Yeah. Oh, false. Well, it's just because I can't type when I'm trying to do a demo. There it is. Okay, so I got rid of the left arm, and the right or the left leg code depended upon that because I use it to align it. Later on, I do a calculation. Basically, what it says is if the left arm moves, the left leg depends on that position. It also moves. Poor man's code. It's just the way I coded this up. So let's go ahead and turn everything back on. And let's go ahead and take a look at some more of the example. Okay. Another bit that I did here, really, this was, I did this in order to prepare for the posing example. There's an example here where if you run the posable doll, you can position your doll just the way you like it. Hit the save button, quit, go back into the posable doll and click restore, and it will pose the doll in that position. The way I achieved that was by saving the position of the body parts, and there's two parts to that. First, I kept track of all the body parts, and then I iterated over the list when you click save, and I saved those positions into a JSON encoded file using code that we talked about 2 weeks ago for loading, saving, and restoring tables to disk or persistent storage. And then similarly, when I press restore, it loads the file if it's found, iterates over the contents and looks at the list of current body parts and assigns their X and Y positions as well as their rotations. So in our Draggable Doll, I knew I was going to do that, so I just put a body parts table, a table that currently has nothing in it, and then every time I created a body part, I simply added it to the table using a named field like torso or head. Make this a little bigger so you can read it, which stores that as a text indexed field called torso in the table, which allows me to later iterate over it with the 4kV iteration, or the pairs iterator. I can show that to you later if people want.
So what I just heard you say though is that if someone were wanting to make a game where they had objects in a room that you could arrange, or dresses that you could dress characters in, or anything like that, you could do that and then save it, which maybe you have an auto save for the player, and then when they come back to their work, it's saved in the same position. So
Yep.
this sampler basically provides a working example of something like that.
Yeah, this provides, in the posable example, another file called, I think called posable.lua, provides a base sample from which you could start to do some of those things if you wanted to. Now, it's not going to solve everything. For example, you said something about putting a dress on a character.
Yeah.
And if you had, say, 2 dress examples, then you'd have to ramp up your code a little bit to look at the saved content and decide which dress to put on. And it's not quite as simple, but it's almost exactly the same. I mean, it still iterates, examines the data, and makes a decision based on the data. So that's our body parts table. Then I got a bunch of different parameters here that let us mess with the visible or the visual, like the width, thickness of the arm, the length of the arm, how far the head is from the body. So, example, if you want to give it a long neck. And now we've got a very long neck. That's nice. George has got a long neck. Let's see, what else can we do here? Joint radius. Joint radius has to do with the rounding on the rectangles. I talked about this last week. And arm segment thickness. Anyways, I'm not going to mess with these. People can play with them. It's not 100% robust code. I think that as you mess with it, it's going to make things look a little bit visually goofy. But it's a starting point to understand what I've done here. Alright, almost ready to talk about the doll. The only other thing was I knew that I was going to have gravity in this example, and I wanted to make sure that the body didn't just fall off the screen. Very zen pose for George there, and he's doing a little yoga. Anyways, so I put a block at the bottom of the screen. It has a static body, as you can see here, which means that under gravity it's not going to move. No forces can move it. It's going to stay in the same position all of the time unless I move it with my code. And it has no special filter, so it has the default everything hits me, I hit everything body, which is by default, if you do not define a filter, all objects will collide with and respond to collisions with all other objects. It's the starting point for collisions. And so, let's take a look at the torso to start with. The torso and the head, let me reload this. Go back to normal. No. Come on, George. No. 2 seconds, please.
So you're putting him back to the way he was?
Yeah, I'm going to put him pretty much back to the way he was, except I'm taking his limbs off, since we're just talking about the torso at this point. So this is the torso. The torso is nothing more than a rectangle with rounded corners. It's kind of boring, but it gives us a nice way to say that we're going to have a shoulder joint and a hip joint, and the leg and whatever they'll rotate around here. And if I had left this square, it'd be a little bit ugly looking in certain positions, so I rounded it off. This is nothing more than a rounded rectangle placed in the content layer, which is the display group that we created above. And then what I do is I say create it 62 pixels wide, 96 pixels tall, and then place it in the center of the screen as far as the X coordinate goes, and 24 pixels above the center of the Y axis. All right, and so then there's angular damping, and angular damping says that when a body is rotating, that if there is any angular damping, it should start to slow down and stop rotating. It will not affect the linear motion of the body. So we can experiment with that in a moment too. And then, as we talked about last week, I set is sleeping allowed to false because I knew that in this example that people would be flipping the gravity on and off. And if the body was allowed to sleep, when you turned on gravity, it would not fall. So, for example, if we set this to true, we reload it, and wait a moment, and what's happening here is we cannot see it, but what happens is the body is going to sleep. We click on gravity, it turns on gravity, but because the body is basically sleeping, the physics engine is ignoring it. It's not going to drop until it's interacted with, and because we can't touch it, it doesn't have any dragging capabilities, it's never going to wake up. So I set is sleeping to false, and now it will fall under gravity. Okay, so this is just giving us something to attach our limbs to. Again, a rag doll is to me nothing more than some kind of body with one or more segments and then limbs attached to it that flop around, and they don't have any limitations on their angle, which not necessarily true. You could change that, but in this case I'm not putting any limits on the rotational angle of the limbs. And that's pretty much it. So let's go ahead and put a head on the doll. Head is nothing more than a marker in this case to make it seem more like a rag doll or a doll. And this head is attached to the body with a weld joint. If I turn on hybrid mode, you'll be able to see, I'm not sure if you can see it well in the video, vaguely you'll see a line between the head and the body, which is telling us that this is a joint connection and that it is connected to the body. We can't see it yet because I can't move it, but if I were to move the body, turn on gravity for example, the head will stay oriented with the body no matter how it turns or moves. Now it's worth noting that a weld joint is not a guarantee of exact distance over time. You can't rely on any of the joints to be precise. The precision of a joint in the game depends on how well the physics engine can handle the calculations it has to achieve within a set time. So what can occur is if you have a very complicated body or a large number of physics bodies with lots of different joints, you can start to see body parts pulling apart or joints starting to separate. If you see that in your game, what's actually occurring is the physics engine is no longer able to keep up with all the work it's supposed to do on a frame-to-frame basis. And so you either need to simplify your game by reducing the number of bodies and joints, or you need to increase the time that the physics engine is allowed to do its work. And so at the beginning of the show I said we can talk about setting velocity iterations, et cetera, et cetera. This is the kind of thing that we would talk about later, and then hopefully I can give some examples of how these things are not behaving properly, and then we can fix them with the features in the physics engine. But I just wanted to point out that people should be aware that joints are not perfect, and so when we get to the car example, you'll see that the car hits the ground and the tire moves a little bit. That might be unexpected to people who don't know what's going on, but that's just the way the engine works. It's not going to be exactly precise 100% of the time. All right, so let's do an arm, and having done one arm, we'll do a leg, and that will pretty much lay out the groundwork for people to understand what's going on here. So let me turn on the arm code. Okay, let me turn off hybrid because that's a little bit distracting. I turned on the whole body, but that's fine. Okay, so the way this arm code works in a nutshell is I have a builder function. It lays out one segment of the arm, and the horizontal bits of the arm and the vertical bits are the legs. And there's a builder function for legs and a builder function for arms. It's worth noting at this point that this is sort of like the traditional layout for a body that you see in graphics programs, either 3D or 2D, sort of like the default pose. And I'm not an artist, so I won't go into them. I'm sure there's many, many reasons why people do this, but for me, the reason I laid this out is because it makes the math simple. I can say that I want my arm to be relative to the center of the body, this high off the belly button if you want, and then so far to the right or left, and it just makes it easy to lay out. Now, if I had tried to lay out the arm at an angle like this, then I would have to calculate. Calculating this joint is easy because I know that the body is here and I can just go up and to the right, but then calculating this arm segment's X position relative to the arm, I'd have to do 2D math. I didn't want to do that. Now I'm really doing 2D math when I do this pose, but the 2D math is quite simple. It's just add a certain Y element, add a certain X element, you're in the right place. It's easy to measure, it's easy to calculate, nothing to it. So that's the reason we're doing this pose, and that allowed me to create a generic arm builder, which always creates a horizontal segment, and a generic leg builder, which always creates a vertical segment. So when I create the right arm, let's find it again. If the right arm code is enabled, which it is, I call the create arm segment function, and it passes back one element, which is the rectangle, and I store it as the right bicep. It passes back a marker, which is this marker here, with the one that's now grayed out, and I store it as temporary because I'm knowing I'm going to get rid of it. And it passes back another marker, which I store as the right shoulder marker. I don't know why I did that. Oh, I'm sorry. The first marker it passes back is on the right. The second marker it passes back on the left. So, for example, when I create the left forearm, the first marker that passes back is where this red one is, and the second one is this green dot. So, first marker is the rightmost. Second marker is the leftmost marker. This function here, create arm segment, basically I pass in a display group to store everything in, and then an X and a Y position, and that is telling the function place the arm center. I don't know why George did that. George just got a twitch. Place the arm segment right here, the center of it right there. Place this arm segment right here. It's basically saying where to place the center of the object. Arms twitching. All right. The other thing I tell it is how long to make the arm, and how thick to make it, and then what the turn radius is on the arm. And what that does, it's used in the rounded rectangle to choose the rounding for the corners. So let's take a look. Well, before we go, okay, so I passed that back, and I created a second arm segment, which is the forearm, and I placed it a little bit more to the right. At this point, these two would be free-floating, not attached to each other. Then I created two joints. I created a pivot joint, which connects this body to the torso, and this is why I have the markers, because the markers are placed over the ends of the body. So there's a marker here and a marker here. Those positions are where I want the joints to be. So it's a pre-calculated position. My little arm builder has basically told me this is where that joint needs to be, and this is where that joint needs to be. And so what I do is I attach the bicep to the I attach the bicep to the torso, and I place the pivot joint where the shoulder X and Y are. So if you go back and look at the code, you can see that I have a shoulder marker, and that gives me the X and the Y position for the center of that pivot, which is saying that this body, regardless of where it may be positioned, will be attached right here. It's kind of weird. It's kind of interesting and weird and very useful that you can place the joints anywhere relative to the bodies. So for example, as you can see, you may be able to see in this image, these little markers here are where the joints are, and I've kind of placed them all relative to the centers of the bodies. But a joint can be anywhere. For example, let's turn on gravity. I've got a touch joint going on here now, and as you can see, there's a dot here where my cursor is, but there's another dot sort of off-center. The point is that joints can be anywhere relative to the bodies, and so placing a joint at the center of a body is fine, but you may want other behaviors, and so you can place that joint anywhere. And when people are first doing this, they sometimes place their joints incorrectly, and then they're like, why is my body moving strangely? It doesn't make sense. They get strange body motions. So what you need to do is turn on hybrid mode and take a look at these little lines that are drawn between joints, between bodies and their joints, to see what is really going on. So in this case, the two distance joints are connected directly to the center. And we know that that's basically what I know as I wrote the code, that's what I was hoping to achieve, and so it's correct. Let's go back.
Is there a situation where you would want the touch joint to be outside of the object itself?
Absolutely. So think about a lever. How does a lever work? A lever acts upon a body and moves it through some kind of force. And so you may want to create a situation where the body is swinging around a point, but you want that, I don't know, how do you describe this? It's weird. I know what I want to do, but I can't describe the reason I want to do it. I'll say yes. There are cases where you would want the joint to be outside of the body. It's not typical, but it does occur. Most people want the joint to be in the body or in the same position as the body, and typically in the center, but not always. Like
I was thinking of you think major magnet? You think that was something that they used? I know that was, you kind of touched where you wanted the.
They could very well. I'm not 100% sure, but if we look at the joint sampler, there's a thing called a distance joint.
Yeah.
Let's turn on hybrid mode. And a distance joint, what that's saying is object A and object B must always maintain the same distance. They can have a different rotational orientation to each other, but they're not allowed to get any closer. And so I think in Major Magnet, because your character goes around the magnet in the center,
Yeah.
and it does so as soon as you touch the screen. So what they could have done is they might have created a distance joint, and then what would happen is object A, let's say that's the dude flying around, and object B is the magnet, then object A would have been flying around here and would have maintained its, it's hard to do because they're both allowed to move in my example, but would have maintained its velocity, and that would have turned it around the shape. Now, I can tell you right now, that's not all they would have done.
Oh, sure. Because you're jumping from magnet to magnet, which means...
Well, right. So, okay. Let me just go change this example so I can show you exactly what's going here. Distance. Where are you?
And that's okay. I was just curious. That way people could kind of think outside the example there.
While he's making these changes, I think the important thing that everybody needs to remember when you're working with any kind of physics joint is create a small example of what you're trying to do and experiment with it for getting your settings right, and before you're implementing it into your full program. Little bitty demos, not that what Ed has created here is a small demo. This is actually a huge demo with all the inner workings that he's got in here. But the important thing is try the joint in a smaller version of your program for what you're trying to accomplish, and experiment with it in that smaller relationship to make sure that you get the reaction that you're looking for.
Absolutely. People ask questions in the forums, and they're confused because something's not working, and I typically tell them, all right, go make yourself a small test bench that does just the thing you're trying, and then see if it works the way you think it should.
And that applies to everything. It's not just physics. It's anytime you're trying to do something new that you haven't done before, take the time to build it in a smaller program with just that feature. Once you start putting all these features together and you get all this interaction between various features, you might have unexpected reactions to one another. So getting it working independently is that important first step to make sure that your larger program will work.
So what are you doing? You're flailing distance A around there?
Yes, I am. I'm sorry. This is like what I would consider Major Magnet's basic mechanic to be if they chose to do it this way. It's a distance joint, and when B is a static body, the magnet, and A is Major Magnet, and when you throw him around, it maintains its velocity, even though it changes its direction, and its distance to the magnet. Now, I have damping on here, but if I had no damping and I just flung it like that, it would just go around and around and around. It would never stop. And that's exactly basically what they're doing in that game. And then what happens is, consider, they're moving in a straight line, and then you do this, you create this distance joint, and then it forces the body to start traveling in a circle around object B. But then if you suddenly remove this joint, the velocity will be whatever the velocity was on the last frame, which is going to be a straight line, and it will fly off in that direction. Now, I kind of think they did not do it this way, and the reason I think so is because I've experimented with these things, and it's kind of tricky to get the timing to match what the user expects, because there's a slight latency between the tap, the removal of the body, and the response that you expect. Now, maybe they did this and they worked it out. Maybe they changed the number of iterations per second, something. But in my experimentation with things like this, it didn't quite work the way I wanted it to.
Yeah. And he does, Major Magnet does continually spin around the magnet. He doesn't slow down and just sort of hang there if you don't do anything, at least not in my experience.
That's right.
So.
Exactly. So let me put this back.
Okay. Well, cool. Does anybody on the panel have any questions or anything to add?
Yeah, we didn't quite get to the end there, but I think we can leave it.
Okay.
We can leave it. I really wanted to talk about the car example. The car example is so much more fun.
Well,
it's kind of boring.
Well, we can start off with the car example next time.
Yeah, I just want to turn people in the right direction here as far as the doll goes. So the key here is you need to go look at this create arm segment or create leg segment function, which is down towards the bottom of the file. It's a little bit hard to read here as I navigate. And basically what it does is it creates the rectangle, it creates some circles, it mounts the circles to the body, that is the rectangle, and then it just passes them back. It's a very simple builder that creates a certain length, certain position, passes it back. So it looks very complicated. It's because this code line is so long. But there they go. I made it simpler by making it smaller. Just read through the arguments, and it will become more clear. This is why I did it that way, because I wanted people to say the bicep is connected to the body joint or whatever. In this group, the arm segment length and this thickness. Oh, that makes sense. I could have just put numbers in here, but it would have been totally meaningless.
Yeah, and this is good because it's self-describing code, and if you want to organize it differently in your own project, you can, but at least you get the concept down here.
And it shows you how not to do it. It shows you how to lay it out. The one bad thing I did was all those extra markers would be a terrible way to make a ragdoll game because it's too many objects. If I had a dozen ragdolls with that many markers, things would start to fall apart. So.
Okay.
All right.
Well,
I'm just going to look at the car example for fun while you guys talk now.
So next time we're going to talk about the car example and what we'll look at how it's constructed and how.
Yeah. So it's a real simple thing. It's basically a body and a pivot joint. The only thing I wanted to talk about was how you do the motors.
Okay.
The little bit where you make it drive around.
Yeah, let's definitely talk about that next time. Again, I could kind of. I mean, we said this last time, but I can kind of see a simple game just in what you're doing there. I mean, it seems like.
Yeah. I mean, this is exactly. I mean, what was that game that came out 4 years ago? Was the one where the jelly wheel thingy, jelly car.
I don't remember that one. Does anybody remember that one?
No.
It was
jelly car.
It was wildly popular.
What was the premise of it?
Sir?
What was the premise?
It was a car whose you could change the size of the wheels and I think the body, and it had to navigate a world that basically it had to navigate a world under its own basic power, and it would tend to tip over and stuff like that. And all you could do was modify like the size of the body and the wheels to navigate the world. It drove at the same speed. The wheels turned. It wasn't under your control, and so all you had to do was like get the right size at the right time. But it was a wonderful example because what they did was they had soft body physics mixed with basic physics like we've got here. We're just rotating joints and stuff like that. So.
Did that one go over hills and stuff like that? Did it go?
Oh yeah, over hills and through gates. And
I may remember that one vaguely.
Yeah.
Yeah, that sounds like a lot of fun. So yeah, I could see catching things from the sky and having that alter the way that the cart interacts with the world, and then adjusting gravity periodically just to mess things up and try to maintain your load. Yeah, that would be cool.
Yeah, I mean, I did this example. I'm like, I don't want to do the show anymore. I want to go make a game.
Yeah. I want to go play with my cart.
I just want to play with my car. I don't even want to make something. I just want to play with it. I find myself like, watch this. Let me reload it.
Well, who doesn't just want to play with their wagon, right? I mean, come on.
I discovered something I didn't know. So this body is attached to this body, and it tries to keep it in place, but if you spin the tire, the tire's got momentum, and the momentum bleeds off into the joint, and it causes the body to rotate because there's no gravity.
I see.
I did not know that.
That's an interesting. See, there you go. That's a Space Odyssey type game. All right. We'll talk about more of that later next Monday. So be sure to tune in for that, and also be sure to check the show notes for links to this example. So all the code is here. It's all provided, and then I definitely recommend that you go watch last week's show. There's a lot of great tips talked about there, and don't miss it. So we'll be back here next Monday at 12 p.m. Pacific to talk all about mobile app development using Chrome SDK. Till then, have a great week and happy coding.